Hi, my name is Maegen Rochner, professor at the University of Louisville, and we are in Owingsville, Kentucky. We're here collecting core samples from a historic building so that we can collect tree ring data that can not only help us potentially date when the building was constructed, but can provide us valuable paleo-environmental information for this region of Kentucky. The information we could get from tree rings from historic buildings is quite a bit. We can use the tree rings to look at past climate, so that can include things like temperature, precipitation, or drought. We can also look within the tree ring records for growth changes that might be related to disturbances in the ecosystem, things like insects, fire, increased competition, wind throw, tornadoes, that could affect the forest and change how quickly or how slowly a tree will grow. Ultimately, what we're able to do is date the tree rings and provide the year that the tree was cut to construct the building. We believe that this is an 1800s cabin. The homeowners have told us that the structure comes from their farm, which is only 6 miles away and has been relocated to this site, and that farm had been in her family for many generations, potentially back to the Revolutionary War. The procedures that we follow to extract cores from log buildings involve just first observing the logs, sort of scouting the structure, and finding the ones that are most likely to give us the information that we need. So you can see how many rings there are. To properly date material, we do need a minimum number of rings, but here I can tell we're going to be in good shape because you can see quite a few of them. It's pretty slow growth. We are after really old tree ring data. To do paleo environment or paleoclimate reconstructions, we want to go back, at least in the tree ring realm, hundreds to thousands of years in the best cases. And unfortunately, there aren't very many old growth forest or trees left in the state of Kentucky. And log cabins provide one way for us to get this older tree ring data, because essentially the cabin is from old growth forest that was cut down 100, 200 years ago. So the most important thing is bark, that the tree has the outer tissue that tells us when the tree was cut down. It can also have weighty edge, which is the edge just under bark. This one obviously has a lot of problems. So rot is a major issue. We don't have a lot of outer edge, and it's a different species. So we wouldn't really want to work with those. After bark, we also look for condition. We'll look for how solid the log is, whether there's lots of insects, and also if we're going to collide with any things like nails or tree branch scars, stuff like that. And then we'll identify the optimal location for taking a core. We'll also look for locations where we're going to obtain the most amount of rings. Play is the basal end of the log, which is going to be the bottom, which is usually bigger. It's going to also contain more rings because trees start growing from the ground up. And they actually grow like stacking safety cones on top of each other. So actually, like if you core about here, you're going to miss all the years it took the tree to get that tall. All those years exist below that. So the lower we can get on the tree, the more rings we can get. We're getting more of those innermost rings. This is a really nice clear area. It's a pretty big part of the log. It's got bark. I do see a few bug holes here. So I'd probably scoot and kind of go in this clear area. And so you'll put the tag, and depending on kind of how tough the wood is. We do want to try to get as many logs from the different walls as we can, because we're trying to help them understand construction history. And you can really only make inferences about construction if you have a pretty good representative sample from the whole building.
So, and then you'll notice as I'm coring that I'm going to core in a bit, and then I'm going to pull the bit out a little bit to evacuate sawdust.
This is the most ideal situation. We lost a few fragments of bark, but that's perfectly normal. There's a lot of bark here, and these outer parts are pretty fragile. But if we look, we can see our core right there. And the core is actually still inside the log, because all we've done is we've cut around it, and it hasn't broken into pieces. So once you're there, then we take our extractor, and it's going to slide in on the side. It has this little cutting tooth that we're going to turn and cut. So you want to put it sideways and slide it past. And then when you turn it, you'll hear like a pop or a snap as it breaks loose. and then it comes out.
Nice.
We do help to protect the tree from anything that could come in after we've put holes in the building, so we will plug the holes later with sort of wood glue and cork, or sometimes with dowels. So what we do with the core samples after we get them back to the lab, we will take them and we'll put them on wooden core mounts. It kind of stabilizes them and helps preserve them for longer periods of time. It also gives us the ability to sand the cross-sectional surface on the cores to a fine polish so that we can very clearly see but also measure the width of every tree ring in those samples. We'll take those cores and we'll actually scan them to high resolution, and we'll put those scanned images in a software program called Recorder, which helps us digitally measure the widths of every ring in every sample. Then we will match the patterns of growth between all of the different logs in the tree to make sure that we've internally dated all of the material within the building. And then we will attempt to date that pattern against a regional reference pattern that we get from nearby living trees, but also from other archaeological structures. And I like to tell people that it's kind of like running a fingerprint through the system. This cabin will have a distinctive pattern of growth through a period of time. And we run that fingerprint or that pattern through the system against the much longer reference, and we find the point that it matches. And when it does, we have the actual years for every ring, including the year that the tree was cut down. We are trying to collect core samples from all across the state of Kentucky for the project. Our broader goal with the U of L is to be able to reconstruct past climate broadly, even across the state boundaries into more of the southeast. For the CLIMES project, and what I'm looking for in the historic structures is relationships to those climate variables like temperature and precipitation. They can tell us about the paleoclimate conditions in Kentucky, and we can connect those to things like stream flow and potential flooding, and a lot of other information about past environments. Looking for flood signatures and tree rings depends on where you got the tree rings from. In low-lying and floodplain areas that do actually get inundated with water, you can see things that we call flood rings. For example, in oaks, it's very anomalous-looking vessels. Vessels are the features that transport material up and down the tree. And if the tree's inundated in water, that could affect vessel size and number. And we can look for those anomalous features to look for flood years. For instances like this, where the trees probably came from an upland area, we can still do things like reconstruct stream flow and connect high discharge rates reconstructed in the past with potential past flooding events. And we would probably try to relate that with other paleo information or even archival information about past events in Kentucky.